Hello and welcome back. In this part of the module, we will be discussing the bulk of non-renewable sources, namely fossil fuels. Now, fossil fuels have three types. You have coal, petroleum, and natural gas. Now, they are different in terms of their own respective properties. The fossil fuels, of course, are oil or petroleum is in liquid form. Natural gas, of course, gas form, and coal is in its solid form. Now, why are we using fossil fuels to power our society? So, fossil fuels are used as heat energy. So, we use it in terms of combustion and then using the heat from these fossil fuels to create steam. Then, as you know, steam is kinetic energy, becomes mechanical, and then finally electrical energy. But what's so special about fossil fuels, and why are they powering up most of our world? Now, fossil fuels contain hydrocarbon chains. When we say hydrocarbon chains, these are long molecules of carbon. So whenever you cut those carbon in the form of combustion, they produce a lot of heat. And that's why they are ideal whenever you need heat energy. So these hydrocarbon chains are organic in origin. So literally, when we are saying fossil fuels, we are using dead organisms to power our society. Okay, so dead organisms buried millions of years ago in order to power the present. Okay, so fossil fuels have three types as mentioned. So petroleum is liquid in form and mostly can be found in United States and Saudi Arabia. So you already know Saudi Arabia is very rich because they are the main producers of petroleum or oil, which it sells to the rest of the world. So they have a lot of income. Now, United States, of course, will not accept I will not accept that. And so they eventually found their own petroleum resources and competes with Saudi Arabia in terms of providing oil to the rest of the world. There is a lot of competition and politics involved in United States and Saudi Arabia in terms of petroleum, but that's a different topic that you might want to explore on your own. Okay, so coal in comparison to the other types is considered dirty. So the solid form of fossil fuel is dirty because it produces the most amount of greenhouse gases. But despite that, we still use it because it's abundant. It's found in most countries around the world, even the Philippines, and it's cheap. So since it's abundant, it's cheap, so we can use it for cheaper electricity generation. But coal has to be, even though it's abundant, coal came from organisms buried 300 to 400 million years ago. So during the Carboniferous era, there were giant plants that covered the earth, but they eventually died, buried for millions of years, and now we take them out from the earth, and that's what we use as form of energy. Okay, natural gas, it's clean air quotation marks because that's relative as well. In comparison to the other fossil fuels, it produces the least amount of greenhouse gases, but it's still greenhouse gas. Natural gas is basically methane, which when released into the atmosphere also is a form of greenhouse gas. So most of the supply of natural gases is found in Russia. So as I said, it may damage our atmosphere. In addition, whenever we are mining natural gas or looking for natural gas, it damages the terrain, and if the methane gets mixed into our water table, then that could produce like a domino effect of harm into the environment. Okay, so how much does the Philippines rely on fossil fuels? Specifically 75.8% in terms of 2016. So the table that you see on your screen right now is a graph the graph showing you the electricity generation by fuel type. So this is what we use to produce our electricity. So by 2016, as you can see, the blue area is fossil fuels. So that's a combination of mostly coal followed by natural gas and oil. Then we have some renewable energies, which is only 24%. So very dependent on fossil fuels. Even if it's ideal to stop using fossil fuels, the world as well is very dependent on fossil fuels. So 88% of the electricity generated by the world is from fossil fuels. Okay, so again, fossil fuels come from dead organisms or from dead plants and animals. Energy from the sun comes from the sun through photosynthesis of organisms from the biosphere, which will be later consumed by animals. So it's still the energy from the sun is converted into plants, because what plants do is through photosynthesis is to incorporate carbon from the atmosphere and incorporate it into themselves, and thus creating like leaves and stems. So eventually those plants die out and the animals that consume them also die out, but their fossils still contain the energy that it has harvested from the sun. So they are locked into the earth due to geologic processes. They have been buried into the earth, and that's what we mine for. So after being subjected to heat and fresh pressure, they become these different types of fossil fuels. Okay, so the first fossil fuel that we will go look into is your petroleum/oil. So petroleum is from the Greek word petra, which means rock, plus oleum, which is oil. So literally, it means oil from rocks. So petroleum is naturally occurring yellow to black liquid found in geological formations beneath the Earth's surface. And in order to use petroleum in our society, you have to process it in the process called fractional distillation. So crude oil, which we take from the environment, must be processed again through fractional distillation. So as I have mentioned in the previous slides, whenever how petroleum and natural gas are formed. So you have marine plants and animals, either zooplanktons and algae. So millions and millions of zooplanktons and algae eventually died way back in the history of the earth, and their bodies or their those organisms get buried underneath the Earth's surface. Now, due to the heat and pressure of being underneath the ocean, they turn into oil or natural gas. Sometimes the ocean is still there, so we have to drill through the ocean through the water and into the ocean floor. But sometimes there are areas wherein the ocean is no longer there, but it will still contain, the earth underneath will still contain the oil and natural gas deposits. So those are the sources where we tap and harvest or mine our energy source. Okay. So again, this process of forming petroleum and natural gas takes millions of years. You need millions of years of organisms, 100 years of organisms dying, like life cycles of organisms, in order to provide for the energy that we need today. Petroleum, of course, is the liquefied form, but natural gas comes close, because whenever you have processes like these, geologic processes, natural gas goes with petroleum and coal. So whenever there is petroleum and coal, because in the burying and the pressure underneath the earth, there is going to be a byproduct, which is the natural gas. Okay, so petroleum oil in its natural form is the unprocessed one, so crude oil. And later on, once we process it through fractional distillation, it will become the various petroleum products that we use in our everyday living. So just some examples are fuel oil and gasoline. Okay, so this is fractional distillation. So when we say fractional distillation, we will separate the mixture. So this original mixture of crude oil, we will subject it into heat. Now, because crude oil is made up of different hydrocarbon chains, it will actually separate because the hydrocarbon chains are in different length. So when you subject it into heat, the heavier hydrocarbon chains, or the one with longer chains, will sink into the bottom, so it will create its own fraction, while the lighter ones, or the one with shorter hydrocarbon chains, will rise or float up. Okay, so first fractional distillation fraction, the lighter of all the hydrocarbon chains can be used to become our petroleum gas, and that's what we use in cooking and sometimes to power motorcycles as well. Then the next fraction would be your gasoline, so that's what we use for smaller cars. Next, naphtha. So naphtha is common actually, so that's still from crude oil. So naphtha is used to like flammable material. So if you're going to buy oil or like gas for camping, that is actually naphtha. It's also mixed into thinners and paints. Okay, next you have your next fraction would be paraffin. So that's the type of oil we use to power our airplanes. Next is diesel. So it's considered as one of the dirtier in terms of like comparing it to gasoline, but it's ideal to power larger vehicles. So trucks and large moving vehicles, we use diesel. Okay, next, to power our tankers or our boats, you have your fuel oil. Next, lubricating oil. So when your door or your gate is creaky, that's actually what we use, your lubricating oil. And then finally, the heaviest of the hydrocarbon chains, we just use them to form our road. So if you're wondering why our roads are like grayish or blackish in color, because it contains some crude oil. Okay, so as you can see, like we have used a lot, like all parts of the crude oil has been used, and our society is very dependent on all those products already. Now, you might be asking, Ma'am, where does petroleum jelly comes? Like, does petroleum jelly come from crude oil? And you might laugh a bit because petroleum jelly might not be part of fossil fuels, but actually, petroleum jelly is from crude oil. So whenever we are processing petroleum gas or gasoline, there were some byproducts, and those byproducts is what workers used to put in their burns and cuts. Then eventually those have started to be marketed by Vaseline, but petroleum jelly is actually from fossil fuels. So there are articles online which actually advertise that they are not from animals or they're vegan, but I'm not sure if you could classify it as vegan or like animal friendly because it's from fossil fuels. Petroleum jelly is from fossil fuels. That's why you don't eat it. It's dangerous to consume because it's not from plants or animals or vegetables. So you could read more of that about the history of petroleum jelly. So just my point is petroleum jelly is from fossil fuels. Okay, so much for that. Next, we have your coal. So the coal is the cheaper version of our fossil fuel. So flammable black hard rock used as a solid fossil fuel. So you might be wondering, what rock? Fossil fuels? But yeah, actually, our coal is a form of rock. because these are sedimentary rocks. So imagine like giant plants or giant trees covering the whole of the earth, then eventually those trees die out. Since they are buried deep into the earth, they become fossilized, and fossils are a form of sedimentary rocks. So it's mainly made up of 65 to 95% carbon and also contains hydrogen, sulfur, oxygen, and nitrogen. And there are different types based on the concentration of carbon they contain. Now, first you have lignite, bituminous coal, then you have your bituminous coal, and then finally anthracite. So the ranking is based on how much energy or how much heat the coal can provide. So of course, the glossy one has the highest rank, anthracite, and it produces most of the energy. So it contains 86 to 97% carbon, okay, and have the highest heating rank. Bituminous has 45 to 86%. Subbituminous contains 35 to 45, and also lignite contains 25 to 35. Okay, so lignite coal deposits tend to be relatively young and were not subjected to extreme heat and pressure. So this is very different, okay? This is very different from charcoal. So charcoal has been processed recently. It's just wood that has been charred a little and then sold to us, but coal has to come from millions of years ago and then subjected to heat and pressure to be in this form of concentrated carbon. Okay, so how was coal formed? So before the dinosaurs, there were giant plants. So that's what I mentioned, the Carboniferous period. Then after millions of years, they were buried deep into the earth. And that's what we look for in terms of mining coal. Okay, next, natural gas. So as I have mentioned in the earlier slides, they form side by side with petroleum and coal because they are a byproduct. So because the decomposing organisms are subjected to so much heat and pressure, the methane actually becomes the byproduct. Yeah, there. So consists mainly of methane, a compound with 1 carbon atom and 4 hydrogen atoms. Okay, so they exist with your liquid and gases. Okay, so some places have large amount of natural gas, so you will have large spaces underneath the earth and it will contain large natural gas. But in some locations, tiny pores of rock faces have natural gas. But combining those tiny pores, you could harvest a lot of natural gas. So formations of shale, sandstone, so can contain pores, and those pores may contain natural gas. So those types are called shale gas or tight gas. Okay. So natural gas also occurs in coal deposits as mentioned and is called coal bed methane. Okay. So how do we process the natural gas? First, you have your gas fields, so either coal beds or oil. So you isolate the gas from these locations and you bring them to a processing plant. In the processing plant, they will be odorized because methane in its natural form does not smell like anything. They are odorless, so they are dangerous because they're combustible and you can't smell them. So in the processing plant, they infuse it to have odor so that we can easily detect them in case there's a leakage. Then they will be compressed in containers and then transferred later on. So in the transmission, it could be through pipelines or containers. It could be in the form of liquefied natural gas, and then we could transport that, or we could direct them into large industrial corporations or to power plants. Okay, and then those will be distributed either in residential homes or in commercial to be sold to residential homes and businesses. Okay, now we all know that fossil fuels has its own environmental concerns, and fossil fuels has been the cause of global warming basically, because carbon dioxide have increased the global emissions, or the carbon dioxide emissions, by 43%. I mean, fossil fuels have produced 43% of global emissions. Okay, so it causes air and water pollutions and is harming the environment. We are trying to replace it by alternative renewable sources. So that's the pledge of the most of the European Union actually. So recently the European Union signed an agreement that they will try to reduce the amount of fossil fuels to zero. They are trying to eradicate fossil fuel usage because it is contributing a lot to climate change. Now, in order to control climate change, or like to lessen the effects, we have to stop using fossil fuels as soon as possible. And to do that, we have to shift our economy from being fossil fuel dependent into renewable sources to, dependent to renewable sources or alternative sources of energy. Again, I would like to highlight that fossil fuels is not sustainable energy source. We have mentioned that fossil fuels must come from dead microorganisms. There's gonna be a limit of how many dead microorganisms you can mine out and use for our everyday life. If you can remember the graph I showed you in the earlier slide, actually showing it to you now. We as humanity have increased greatly. So from the 1900s, we started to consume a lot of fossil fuels. So how long can we sustain that large usage of fossil fuels? And actually, scientists have an answer to that question. Okay, so just want to show you this graph first. So this is the global carbon emissions from fossil fuels from 1900s to 2014. So I have shown you that during the 1900s, that's the start of the growth of the fossil fuel usage. And as you can see, with the growth of the fossil fuel usage, we also increased our carbon emissions. So we have increased about like 90% of our fossil fuels since the 1900s, of carbon emissions since the 1900s. So we have to control that because we cannot afford having more carbon emissions in our atmosphere, and fossil fuels have a limit, and scientists actually have the answer. So when will actually fossil fuels run out? When will we reach the limit wherein we can longer find any buried fossilized organisms to power our society? So if we are working with what we have right now, the oil plantations that we have right now, and we won't find any more, oil will end by 2052. Gas will end by 2060, and coal will end by 2090. So this is not just some random speculation I found in the internet. This is from a blog site run by Stanford University. So quite reliable. But even if these numbers are not exact, or these dates are not exact, we know that within our century, the fossil fuels will eventually run out, and it's time to look for alternative sources. Now, in the next parts of our modules, we will be looking at the alternative sources of energy. But for this video, it's quite long now. That's it for now. See you in the next video.